Hello students, welcome to the next lecture on the PY question series of the IIT JAM statistics. Today I will explain you how you can solve the testing of hypothesis related problem. Myself Dr. Harish Garg. You can follow my YouTube channel Dr. Harish Garg, where you can find this PY question series as well as the IIT JAM solution. And you can see both mathematics and statistics solutions is available in this playlist. And you can find the Kramer-Rao sequence, eigenvalue, all are available in this playlist. And also all these questions are explained with the help of the shortcut tricks. Now, so before I start with the directly to the PY question, what is the shortcut tricks and the terminology I have used? H0 is always with a null hypothesis, H1 is the alternative, and the critical region is denoted by W. Then whenever you are talking about the testing of hypothesis, you are always called as the type 1 error, which is generally denoted by alpha, type 2 error, which is generally denoted by beta, and the power of the test is denoted by 1 minus beta. Then the definition of the type 1 error, or called as a size or the level, is collection of all those x which belongs to the critical region such that h0 is my true. Similarly, power is same, instead of the h0 it is my h1, and this is my 1 minus beta, so I can find the beta is 1 minus this, or you can find the w complement over the h1. So based on these simple tricks, I can solve each PY question easily. Now you can simply scan and join my WhatsApp group of the IIT JAM if you are new to my WhatsApp videos. Okay, so firstly you should remember that. Fine. Remember that, for example, in this case x is my binomial. So you must remember what is the PDF of the binomial distribution. Clear? Then the test has size and power. So first of all, what is the size is? Collection of all those x in the critical region divided by, condition is h0 is 2. So what is that? Critical region is x less than or equal to 1. h0 is, theta is my 3 over 4. Fine. So it means it is x is equal to 0 and x is equal to 1. Now one more tips will give you. Whenever the question is related to the size and power, both questions, fine. So you can write the PDF firstly. It is ncx theta raised to power x 1 minus theta raised to power 3 minus x. Fine. Now I can substitute it. It means x is equal to 0 and x is equal to 1. So theta in this case is 3 by 4. So 3c0 is 1, theta is my 0, and 1 over 4 raised to power 3, plus 3c1 is my 3, 3 over 4 raised to power 1, 1 over 4 raised to power 2. So it is 1 over 4 raised to power is a 64. It is 3, 9 over 64. It's a 10 divided by 64. So that means 5 by 32. So these two options are cancelled. How you can find the power? Power is same. X belongs to the W, provided h1 is my true. So h1 is my 1 over 4, and it is x less than 0, x less than 1. So 3c0, h1 is my 1 over 4, 3 over 4 raised to power 3, plus 3c1, 1 over 4, 3 over 4 power 2. So can you get the answer of this? 3c0 is 1, so 27 over 64, it is 27 over 64. So the right answer is 27 over 32. A is my correct answer. Look at this another one. Which of the following is my test is given to you? This is x bar, type 1 and type 2. Okay, so alpha 1 is for the test 1. So that means probability x1 is a rejection region. Remember, if the region is given as accepted, you can find its complement. This condition, what is h0 is? 2.5. Fine. So it means under the h0, this distribution is my 2.5 comma 1. So what is that? I can convert into the z. So it will be 4 minus 2 divided by sigma 1. So that means it will be z is greater than of 1.5. Same I can find for the alpha 2. Alpha 2 is x bar, which is greater than of 3, provided this one. What is the distribution of the x bar? It's a normal distribution. This 1 over n is my 9. So I can substitute again, I can change into the z. So 3 minus 2.5 divided by standard deviation. Fine. So what is Z is greater than, it's a 0.5, 1.5. So clearly say both are my correct option. Fine. Now we are talking about the beta. What is the beta? Is type 2 error. So what is the type 2 error? I can found the power. Fine. Or I can say x belongs to the w complement provided h1 is my true. So what is that? W complement, that's the opposite of this. x1 is less than or equal to 4, h1 4. So what is that? It is p. If I convert into the z, 4 minus 4 is 0 here. What is my beta 2? It is probability x bar. What is the opposite of this? Is less than or equal to 3 when is my 4. So if I substitute again, it is z is less than of 3 minus 4 over 1 over 3. So clearly say this is my minus 3. Fine. Now clearly say this number is my 0.5. So definitely beta 1 is greater than of beta 2. So beta 1 is greater than of beta 2 is the right answer of this problem. Okay, look at this one. H0 is here, critical region is my here. So this is my W. It means your target is to find x belongs to W size H0. So that means x is equal to 2 plus x is equal to 3 when H0 this condition hold. So what is x is equal to 2? This value plus this. If you add them, if I take 6 is my LCM, it is 3. If I add them, it's a 4. If I add them 2, it's my minus alpha 2. Fine. Whenever alpha 1 plus alpha 2 is my 1, it's a 4 because 2 is the LCM. So it's a 4 alpha 2 minus alpha 2 over 6. It is 1 over 2 alpha 2. Now since, remember, now since under the H node alpha 1 and alpha 2 are unknown, fine, because sum can be 1 by any pair. Whenever it is unknown, you always take the supremum of this. What is the alpha 2? What is the range of the alpha 2 is 0 and 1. What is the maximum value of this? Is 1. So it is a half into 1 is my half. So the size is my half. So B and D options are cancelled out. Then your target is to find the power. Power is again same provided H1 is my true. So I can substitute again 2 and 3 provided H1 both are my 0. So I can substitute here both are my 0. So it will be 2 over 6, 1 over 3. So it will be 4 over 6. 2 over 3 is the right answer of this problem. Now look at this one. Now it's exponential distribution. So firstly, I will tell you the tips. Whenever you have f satisfied my exponential distribution, what is the PDF is 1 over b minus a. Whenever you have the exponential distribution, always write in the CDF. CDF is x minus a over b minus a. Fine. Now under the H node, what is my function is? Function belongs to 1 comma 2. So the PDF is 1 over 1. CDF is x minus 1 over 1. Then I can found the size. So alpha, x belongs to the critical region is greater than 1 provided H naught is my here. So I can write this in terms of the CDF. This is x less than or equal to 1. What is that? This is f of 1. So I can substitute here. What is the answer of this? 1 minus 1 is 0. Fine. Or if you don't want to use the CDF, then from here you can see x is greater than 1. So I can integrate over this domain 1 to 2. So 1 to 2, 1 over 1 dx, which is again as this one. Fine. So the size is 0 is the cancel. Now when you are talking about the power, you have to need the H1. What is the PDF of this? Uniform distribution of 2. So 2 comma 3. So PDF is 1 over 1. CDF is x minus 2 over 3 minus 2 1. Whenever x lies between 2 to 3. So what is the power is? Probability x greater than 1 provided H1. So I can, what is the x greater than 1? You can see none of them x greater than 1 means, okay, you can write this as f of 1. So f of 1 is not, because this number is 2 to 3, otherwise 0. So this number is my 0. The answer is 1 is the right answer. Or otherwise you can solve from here. I can integrate from 1 to 3 of PDF is 1. So I can break from the 1 to 2 and 2 to 3, again you will get as the 1 is the right answer. Okay, look at this another one. A coin toss 4 times, P is the probability. So it means it follows the binomial distribution with the probability. A rejection if, so W will be my 0 and 4. The type 1 error and the type 2 error. What is the PDF is 4cx, P raised to power x, Q raised to power 4 minus x. So what is the alpha? Probability x is equal to 0, probability x is equal to 4 when binomial will happens for this pair. So I can substitute this. 4c0 is a 1, P raised to power x is a 1, Q is my half power 4. X is equal to 4, 4c4 is my 1, P is my 4 and Q will be 1. So it is 1 over 16, 2 over 16 is 1 over 8. So this option cancel, this option cancel. Type 2 error, that is a beta. Beta means you have to find the probability in the x complement over the h1. Fine. Or because 0 and 4 opposite will be 1, 2 and 3. Or otherwise I can found the 1 minus of this one. So that means 1 minus x belongs to the W means x is equal to 0 and x is equal to 4, provided h1 will be my here. So what is that? H1 is 3 by 4 because it is not equal to this one. So I can substitute here. 4c0 is again 1, P raised to power 0, x is 0, Q raised to power 4. So 3 over 4 raised to power 4. 4c4 is 1, P raised to power 4, sorry, is a Q. So Q is my 1. Fine. And 4c4 is 1. So 3 over 4 raised to power 4. Now you can use your calculator and you can solve this. And let me quickly solve this. It will be my 87 over 128. You can solve this by using the calculator. You will get as 87. 87 over 128 is the right answer. Again, it's a uniform distribution. So always remember, what is the H0? You have to find the H1 because my target is to find the power. What is my power is? Probability x greater than 2 over 3 provided H1. Where is the H1 is? This one. So under the H1, what is my PDF? It will be half and 3 by 2. Fine. So what is the PDF is? 1 over this from half to 3 by 2 and the CDF is x minus lower limit divided by the range whenever it's a half to 3 by 2. So I can write this in the CDF form 1 minus f of 2 by 3. So 2 by 3 lies in between them. So I can substitute here 1 minus 2 over 3 minus 1 over 2. So 6 is LCM. 4 minus 3, 1 over 6, 5 over 6 is the correct answer of the problem. Always remember student, whenever you have the uniform distribution, write the PDF and the CDF form. It's a very useful without using the integration sign. Okay, alpha and beta you have to find. X follows the exponential distribution. Mean is this, so the parameter will be here. H0, H1 and so on. So firstly I can find the alpha. Probability critical region is a rejection. X greater than equal to 3 provided H0. H0 is my 2. Fine. I can write, okay. Another tips for you. I hope you all knows if x follows the exponential distribution lambda, then what is the PDF is? Lambda e raised to power minus lambda x. What is the CDF of this? CDF is 1 minus e raised to power minus lambda x. If you know the CDF, then it's a very easy for you. I can write this number in terms of here because this is the continuous distribution, so I can return this number as f of 3. So what is the f of 3? I can use this number. So it is 1 minus lambda corresponding to this is 2 into h is my 3. So it is e raised to power minus 6. This option cancel, this option cancel. Fine. Or if you don't want to use this CDF, you can integrate from 3 to infinity of lambda is my 2 e raised to power minus 2x. Otherwise you can integrate them. That's why I'm always prefer to use the CDF. Okay, next one is the power. So how you can use the power is, that means x belongs to the w complement over the h1. So what is the opposite of this? X strictly less than 3, h1 is my 4. So I can write this number in the CDF, which is itself the CDF. So I can write here 1 minus 3, lambda is my 4. So 1 minus e raised to power minus. So A is my right answer of this problem. Always remember, whatever the distribution you have, you can write in the CDF form. Okay, this is my discrete problem. Fine. Critical reason is my this alpha. Probability of x greater than 3 by 2 under the h naught. H naught is my here. So which case is there? 3 by 2, 1.5. These two cases. So what is that? The sum of this. So alpha will be 0.2 plus 0.1, 0.3. So this option cancel. Then the power. What is the power means? X is greater than of critical reason provided h1 is my true. h1 is my here. So x greater than 3 by 2. Again this number. So the answer will be 0.3, 0.4. So 0.7 is the right answer of this problem. Okay, your target is to find the power of the test. So I can write here firstly power is probability critical reason is this number. Fine. So that means summation of xi minus summation of yi is my 0. Fine. Greater than 0, sir. Provided h1. Where is the h1 is? This one. Now, firstly I can find the distribution. So if xi is follows the normal distribution of this number, then can you find this distribution? Again it follows the normal distribution with the parameter n. N is my 4 into theta 1. Variance of this will be 4 into sigma square. Similarly yi follows the normal distribution. So what is that distribution is 4 theta 2 4 sigma square. Fine. Then how I can solve this one? Again very simple. So whenever you are talking, I can convert into the z. So firstly I can found this distribution. So that means summation of xi minus summation of yi. If I call this is my h. So what is the mean of the h? I can find the mean of this. So it will be the 4 minus 4 this one. What is the variance of this? So variance is always the positive quantity, 4 sigma square, 4 sigma square. Fine. Now, so I can see my target is to find the probability h greater than 0 under this one. I can convert into the z. So what is the mean of this? 0 minus 4 theta 1 minus plus this divided by variance. This is 8 sigma square. Fine. So what is that theta 1, theta 2? I can substitute here. So the numerator value will be 4 theta 2 minus 4 theta 1. So it will be 4 minus 4 root 2. So it's a minus 4 root 2. Sigma square is my 4. So it is my 32. Fine. So 32 means 4 root 2. So what does it mean? Probability of z is greater than minus 1. Fine. So what does it mean is your answer is minus 1 here, this number. So definitely it should be greater than of the 0.5. All are fine. So I can return this number is 1 minus CDF of z less than of minus 1. So what is that? You all know, or otherwise in your examination paper the values are given to you. So this value in your examination paper, this value is given to you as here. So probability z less than of 1 this value is given to you as 0.8413. Fine. So if this value is given to you, the same value I have this number of this. So that means this is the right answer. Okay, look at this one. Which distribution here? X follows the Bernoulli distribution with parameter 1 minus q, because x is equal to 1 is my here. Then x1 plus x2. So what is this distribution? It follows my binomial distribution with the parameter 2 and 1 minus theta. Then alpha and beta are there. What is that? H0 is this, H1 is my this. So fine. So what is this critical reason is, if I call this is my y, so my target is to find y is less than 2 under the H0 here. Fine. So it's a binomial distribution. So it is y is equal to 0, y is equal to 1 when theta is 0.2. So I can apply the binomial distribution 2cx q p raised to power x and q raised to power 2 minus x. So if I substitute y is equal to 0, so if I call this is my y, this is y, this is y, 2c0 is 1, y is equal to 0, this is 1, theta is my 0.2 raised to power 2 plus 2c1 is my 2, 1 minus 0.2 raised to power 1, 0.2 raised to power 2 minus 1. So what is the answer is 0.04. This is again 0.04, so it's a 0.08, so 0.12. Where is the error? It's a 0.36. It's not. Can you check it? Where is the error? So it's a y. Y is my less than 2. Fine. So when y is less than 2, it will be x0, x1. So once it is a x0, it is a 2c0 is 1, theta is a 0.8 raised to power 0, and it's fine. So it is a it's a 0.8. So it's a 0.8 into 0.2 is a 0.16 into 2 is 0.32. So once 0.32 means 0.36. So alpha first component 0.36. Same thing I can do for this beta. What is that? Power. Power is my, I can take all those collections over the H1. H1 is my, now this case, fine. So y is less than 2. So that means y is equal to 0, y is equal to 1, but theta is my here. So it's a 2c01, anything power 0 is 1, theta is my 0.4 square plus 2c1, theta is my 0.4, it's a 0.6, it is my 0.4 of 1. So it's a 0.16, it's a 2, it's a 0.24. So 0.16, 0.48. So 464.064. D is my right answer. This is the wrong answer. Again, X follows by uniform distribution. So I can write in the CDF. So my target is to find the alpha and beta both. So for the alpha, this is X greater than or equal to 3.5. Fine. So firstly, when H0, alpha is under the H0. So when H0, what is my uniform distribution? 2, 4. So the PDF is 1 over 2. CDF is X minus 2 over 2 whenever X lies between this number. So I can write this is in the terms of the CDF. It is 3.5. So what is that? 3.5 lies here. I can substitute this 3.5 minus 2 divided by 2. So it will be, if I take the LCM, it is 3.5 divided by 2. Fine. Now what is the beta is? Power. So that means probability of X greater than or equal to 3.5 under the H1. So when you have the H1, what is my uniform distribution? Theta is 3, 9. PDF is 1 over 6. CDF is X minus 3 divided by 6 whenever 3 is less than of 9. So again, I can return this number is 1 minus this. So 3.5 I can return here. So 0.5 divided by 6. So it's a 5.5 over 6. So now final answer is alpha plus beta. 6 is LCM. I can multiply by 3. 10.5 plus 5.5. So it is a 6. 16 over 6. 8 over 3 is the right answer of this problem. Fine. You can see it's a 3.5. If you is it fine? It's a 0.5. No. So the 2 plus 2, this is wrong. If I take the LCM, 2 plus 2 is 4 minus 3.5. So it is a 0.5. So it's a 0.5. If you take the LCM 3, it's a 1.5. So once you take the LCM as 1.5, it is my 7 by 6. So 7 by 6 is the correct answer of the problem. You can scan and join my WhatsApp group if you are interested to learn many tricks. Okay, the minimum sample size type 1 error. What is given to you? This is basically x bar is greater than 4. Fine. So if xi's are here, what is the distribution of the x bar? Normal distribution 1 over n is my here. So alpha, what is the alpha is probability of x bar is greater than 3 by 4 when h naught is my true. What is the h naught is this. So under the h naught, what is my x bar? Normal distribution 0, 1 over n. Now you can convert into the z. So 3 over 4 minus mean over standard deviation. So this comes to be as 0.05. So I can return this is probability of z greater than of 3 root n over 4, which is less than of 0.05. Fine. And we all know when the probability will be less than of 0 in the normal distribution. So this number is my 1.645. Fine. So what is the meaning? This is greater than. Fine. Now can you find the value of the n? Fine. So root n will be greater than or equal to 4 into 1.645 over 3. So let me calculate it by my calculator, and once you do this calculation, it's a 4.8 something. So what is the minimum numbers? It's a 5. So that's a 5 is the right answer. Okay, look at this one. It's a discrete distribution. So xi follows my Bernoulli distribution. What is the parameter is? What is the value at x is equal to 1? So from here you can see the probability is my 1. So that's a here. Then the sum of these xi's, it means it follows my binomial distribution with the parameter n is my 4, probability is my p. Then alpha is my size, and here that's it. Okay, so if I call this is my y, so what is the PDF of this function? So 4cy p raised to power y 1 minus p 4 minus y. So what is my alpha is? What is the critical reason? Y. Y is greater than 3 when h naught is my true. Fine. So I can write it is only 4 because it's greater than 3 of this. So 4c4 p raised to power 4, and this value will be here. So 4c4 is 1, p is my here. So 3 raised to power 4 over 4 raised to power 4. Now what is the gamma is? Gamma is my power. So that means this critical reason when h1 is my true. So I can write this is y is equal to 4 again. So when y is equal to 4, when h1 is 4 over 5 raised to power 4. So what is the alpha plus gamma? So 3 raised to power 4, 4 raised to power 4. So 4 raised to power 4 over 5 raised to power 4. So again you can do your calculator, and let me calculate this quickly. So this number is 0.726 is the right answer. Fine. So it's a 2 decimal places, you can change them into the 0.73. fine, or you may write as a 0.72 also. So answer will always be given in the form of the interval like 0.71 to 0.74. Okay, look at this another one. Again it's a uniform distribution. H0 is my this. I have to target alpha. What is the critical reason is rejected if and only if x is greater than 0.75 and beta is my type 2 error. That means I can say x the opposite of this less than or equal to 0.57. This is when h1 is true, this is when h0 is true. So under the h0, what is my uniform distribution? Is a 1. This is a 0, 1. What is the CDF of this? X minus 0 over a range. So that means whenever x lies between here. However, when you have the h1, what is my uniform distribution is 0, 2. So my CDF is x minus 0 over 2 when x lies between this case. Now I can write this is 1 minus CDF of 0.75. Fine. So 0.75 lies here, so I can substitute here. So this is 0.25. This is automatically a point CDF. Fine. So 0.75 lies here, I can substitute this number as here. So it will be 0.375. So what is the right answer of this? 0.25 plus 0.375. So it will be 625. 0.0625. So you can round off to the 2 decimal places. You can write as a 0.63 is the right answer of this problem. Again, your target is to find the alpha, size and the power. Critical reason is here. Fine. Remember the critical reason is given. X greater than 3 when h0 is given. Beta is my power. So x again greater than 3 when h1 is true. So look at that under the h0. How many cases are there when x greater than 3? These 3 cases. So the answer will be 0.1, 0.1, 0.5, 0.7. Under the h1 again the 4, 5, 6 will satisfied. So the right answer is 0.2, 0.2, 0.2. So it will be 0.6. So what is the alpha plus beta? So it is a 10 into 1.3. So that means 13 is the right answer of the problem. I hope you can like and comment on the video as well. If you really see, it's a very interesting questions. Okay, look at 2022. Exercise are here. Which of the following is my simple null hypothesis? First of all, always remember when you call as the null hypothesis, fine, the h0 always appear in the form of the equality sign. So this is not the equality, cancel out. This is not the equality, cancel. Now look at this statement. How many are the unknown variables? How many are unknown? Mu and sigma both are the unknown. So h0 will involve mu, h0 is involve sigma square both. So this involve only the mu and both are my same, and equality involves, so C is my right. So that's the meaning of the simple. Fine. How many unknowns are there? It must be involved in this option. Okay, look at this one. Can you identify which distribution is here? It is my, again x is 0 and 1, it means it is my Bernoulli distribution. What is the value when x is equal to 1? It is only theta. So x is my here. Summation of xi is my this. So if I call y is my summation of xi, it follows my binomial distribution with the n is my 4, this is my theta. Then which of the following size alpha? What is the size is? Y is greater than or equal to k alpha. Is I can say it's a or simply k. Fine. When h0 is my true. So I can say what is h0 is 4cy theta raised to power y 1 minus theta raised to power 4 minus y. Which of the following is does not exist? Okay, simple. I can start from here. if my k is 0. Fine. So what is happened is a y is greater than equal to 0. Y is greater than equal to 0. That means answer is 1. Fine. It's a greater than equal to 0. So it has all those elements 0, 1, 2, 3, 4. All are my 1. When k is equal to 1. Fine. When k alpha is 1. So it means I can say probability of x greater than equal to 1. How I can find that? I can simply say 1 minus y is equal to 0. So 1 minus, what is the y0 is? What is the h0? What is the h0 is? Half. If I substitute it, 4c0 is 1, is a half raised to power 0, half raised to power 4. So it is 1 minus 1 over 16, it's a 15 over 16. So 15 over 16 is not present. Fine. Okay, anyhow, if I start from the k is equal to 2, it means this is probability of y is greater than or equal to 2. I can say it is 1 minus 0 minus y is 1. So this value I have computed up to here is 15 by 16 minus what is the y is equal to 1. 4c1 is 4, theta half raised to power 1, half raised to power 3. So it is 15 over 16. It is my 4 over 16. So it is 11 over 16. So this option is also correct. It is involve them. So this is a cancel out. Now look at k is equal to 2. Then look at the next option, k is equal to 3. So when k is equal to 3, I can return this number is y is equal to 0, y is equal to 1, y is equal to 2. Fine. When k is equal to 3. So this value I have computed up 11 by 16 up to this part minus 4c2 half of 2 half of 2. So 4c2 will be 6 over 16. So 11 minus 6 is a 5 over 16. So this also appears, this can, because he said does not appears. Now look at the last option, when alpha is equal to y is greater than equal to 4. Fine. So that means when y is greater than equal to 4, I can subtract as 1 minus, okay, y is equal to 4 I can only compute because the maximum value is y 4. I can simply say this number is nothing but y is equal to 4. So it will be 4c4 half raised to power 4 half raised to power 0. So 1 over 16. So this also appears. So only this value which does not satisfy any of this property. So the answer is B is my correct answer. Okay. Xi follows my Poisson distribution with the parameter lambda. This is my critical region. If I say y is summation of xi, so we all know if xi follows the Poisson, the sum will also follow the Poisson with the parameter n is my 4, the 4 times lambda. Which of the following statements are correct? So my target is to find the beta. That means x belongs to w provided h1. So what is the complement of this? That means probability y is strictly less than 5 over the h1. So what is that less than 5? Less than lambda is h1. h1 is my here. Fine. So it means y is equal to 0, y is equal to 1 and up to y is equal to 5. So can you write the PDF of this? E raised to power minus lambda, lambda raised to power x over x factorial. So clearly say e raised to power, when lambda is my h1 1.5, so this number is 6 raised to power x over x factorial. So e raised to power 6 I can take as a common. When x is equal to 0, so 1 over 1. When x is equal to 1 is a 6 over 1 factorial. Then x is equal to 2 is here. X is equal to 3 factorial, 6 4 over 4 factorial, and finally 6 over 5 over 5 factorial. Now you can simplify it and you can use your calculator and you can find its answer. So let me quickly do on my calculation. You can get as 7.49 is the right answer. So 0.7149 greater than no, lies between this no, lies between yes, lies in between no. So C is the correct answer. Okay, look at this another one. Okay, which of the this is my critical region. So if xi follows my normal distribution here, what is that? This is basically x bar. Fine. So x bar will follows my normal distribution with 1 over n. Then what is that? Size alpha, let beta is the power. For a fixed, beta increase. Okay. So my target is to find the beta. So when x bar is greater than of c, c alpha means a c, when h1 is my true. What is h1? Here. Fine. So I can convert this into normal. So it will be c minus delta divided by 1 by root n. Fine. So I can say this number is z is greater than root n c minus delta. Fine. Now look at the options. For the fixed value of the delta, delta is my fix. Beta increases as alpha increases. So this is basically C alpha. So what is the C alpha? Okay, alpha. So alpha is the power size of the test. That means x bar is greater than of C when h naught is 2. That means what is the h naught is? 0. So basically this is my root C n. Fine. So okay, so I can open this bracket also. The first number is basically alpha. Fine. And this number is my here. So this number is basically corresponding to my alpha. Now if you look about the graphically representation, what does it means? This is my alpha. Fine. And beta is my here. The inside is my 0. This is for my beta. Now look at that. For the fixed value of delta, so it means this number is my constant. Fine. As alpha increases, so what will happen if you increase the value of alpha? So it means if firstly I can assume it's a 0.05, then I can increase it, say 0.06, then it number will be here. Fine. And this number, this is my root n c. So what will happen if you increase the alpha? It means this number will be here. So what is that? This number will be decreases. Why? Because this is a 0, this is 1, this is 2 and so on. So when you take this number as something, if it is shifted towards the left hand side, that means this is my decreases. So once it says decreases, this is a constant. So the whole quantity is my, this whole quantity is my decreases. Fine. So once whole quantity will be decreases, that means this number, this complete number is my here. It is also decreases. It will go towards here. Fine. And you know what is the beta is? This probability will be my here. This complete is my beta. Fine. Because it's a power. Fine. This is my beta. So if you shifted this number to be here, what is that beta? This will be increases because it has added this component as well. So that means this is my increases. So beta increases as this number. Fine. Fine. Now look at the second option. What is the second option is? If you fix the value of alpha, it means this number is root n c alpha, root n delta. So this number is my constant. Fine. If you look about the again graphically, so this is my 0. I fix this number. Okay, this is my beta. I fix this number, so it means this number is my constant. And if I increase the delta, if I increases this delta, what does it means? Because of this negative sign, this whole quantity will be decreases because of this negative signs. So again, if this is my here, this number is root n c minus root n delta, and it is a decreases, again it will go to the back side. So what is the my new beta? New beta is my increases, because why increases? You can see this portion is also added. Fine. So beta is also increases. Yes, this is the correct option. Look at this one. If you fix the value of delta, alpha increases, as already discarded here, and this option is also discarded. So A and B are the correct options. Okay, look at this another one. Again you can see what is given to you. X bar is greater than k. What is x bar from here? It's a normal distribution, so 1 over 25. Then size is my 0.5. So this is x bar is greater than k, which is given as a 0.05. So what does it mean? I can convert into the z. H naught 0.5, sorry 5.2 divided by square root of this 1 by 5. This number is my here. Fine. Now find the value of the probability 2. So that means I can take the reverse of this. X bar is less than k when h1 is my true. Again I can change into k minus 5.6 divided by 1.5. So what is that? You can easily know this number will be 1.645 based on the normal distribution. So from here I can find the value of k. 0.2 into 1.645 minus plus 0.2. Fine. So now if I use this calculation, it will come as 5.529. So if I substitute here, it will be 5.529 minus 0.6 divided by here, it number is minus 0.355. And in your examination paper of this, you can see the first page, this number is given to you. 0.355 is 0.6387. This number is given to you. Now it's a positive, it's a negative, so I can change them to be, it's a type 2. So it is fine. Whatever is there, it's the same of this. So it is 1 minus 0.6387. So which number is 0.3613 is the right answer of this problem. Fine. So that's the way you can easily solve this problem. Okay. Look at this another one. X follows my exponential distribution with the parameter 1 over theta. Then h naught is here. What is the observed value is? Okay. W is given to my here. Fine. Okay. Consider the test of h naught for the smaller value of this. That means my target is a smaller value of the observed. What is the observed values? 0.25 plus 0.75 over 2. So that means it is my 0.5. This is your target. Fine. Now can you find the distribution of this? So what is the summation of the distribution? It follows the gamma distribution with the parameter 2 and 1 over theta. Fine. Now once you know if it is there, I can change into twice of this into summation this. It follows my chi-square distribution of twice of this. Now I need to find the value of p, that means alpha, h naught. What is h naught is? This number. So what is the value of the h naught? Under this h naught, it will be my twice of summation xi follows chi-square of 4. So I can substitute the value of this. What is the w is? Summation x1 x2 divided by 2 is 0.5, or I can see summation of the x is less than of 1. Now I can make this value. So I can multiply by 2. So 2 summation of x will be less than of 2. Now this number will be my chi-square 4. It is less than of 2. Now how you can solve this integration? So what is the PDF of the chi-square 4? Fine. Or you can say this is my chi-square 4. So how you can solve that? Okay, so this is my summation of x is at the point h naught. This value will be my gamma of 2, 1. So what is the PDF of the gamma of 2, 1? It is x e raised to power minus x. So I can integrate this portion from 0 to 1 of x e raised to power minus. There is no need to find the chi's because chi-square value is not given to you. So I can simply solve from here. Fine. This is the gamma distribution. So x e raised to power minus x from 0 to 1 because the lower limit is my 0. So what is the integration of this? X plus 1 e raised to power minus x from 0 to 1 If I substitute 1, it's a 2 over e. When I substitute 0, it is a 1. So 1 minus 1 over e is the right answer. So you can divide them, and after division, whatever the solution you can obtain is the correct answer of this problem. Okay, look at this another one. It's a 20. Again, it's a uniform distribution, and it's a maximum of this. Okay, can you find if x follows my uniform distribution of this? As I told you in my unbiased lecture, fine. So what does it mean? X of n, this will follows beta distribution of n comma 1. It's a 2. What is the PDF of this? Fine. Now I need this xn, so it will be xn. It follows beta distribution of 2 comma 1 into theta. So I can apply the PDF of this. It will be my 2x, and if I, because it's a square of this, I can written as 2x by theta square. So that means PDF of xn is 2x by theta square. Fine. Whenever of this, then your target is to find the alpha. Probability of 5 over 4, I call this is my y, is less than 7 by 4 when h0 is 2. Now again, because h0 is not a constant value, so we have to take the supremum. How you can take the supremum? Firstly, I can take x is my 0 to 1. Fine. Or I can y, so y is my 0 to 1, but this number is outside this interval, so that number is my 0. When I take the second number, when 2 is less than of y, so that means I can integrate this portion from 2x by theta square of dx. So it will be x square over theta square. Fine. Clear? Now it will be 1 over theta square is outside, so it's a 49 minus 25 over 16. So it will be 24 divided by 60. Fine, into theta square. Now since this number is not fixed, I have to take the supremum. When this number will be maximum under this domain, this will be maximum because it's a reciprocal, so it will be the maximum at the point 2. So my right answer is 24 over 16 into 2 square. So 4, 6, 3, 8. So 3 over 8 is my correct answer of this problem. Okay, look at this another one. X size follows the binomial. Okay, distribution is here, beta 1 and beta 2. Firstly, what is the distribution of this? So 41, it follows my binomial with the 5 comma theta. So beta will be when x1 follows y is 5 under the h1. h1 is my here. Fine. And they are talking about the 2 by 3. So I can apply the binomial distribution. 1 minus theta of 5 minus 5. 5c5 is 1. Theta is my 2 by 3 raised to power 5, and this value will be 0. So 32 over 3 raised to power 5. This is my beta 1. Beta 2. Again this is my y. Y is greater than or equal to 3 under the h1. Fine. h1 is again 0 point. So I can say this is 3, 4 and 5. Fine. So if I substitute this, it's a 5c3. Theta is my 2 by 3. 1 minus theta of square. 5c4 theta square 1 minus of this 5c5 theta raised to power 5. Fine. Now if you do this calculation, substitute the value of theta here, you will get this as 1 point. No, you will get some answer. Okay, then you can add the values beta 1 plus beta 2, this number plus this number you will get as the required answer. So that value you can easily do with the help of the calculator. You can simply scan and join my WhatsApp group for the various discussions part. We will see the next lecture on the most powerful test and the likelihood test. Till then, you can simply like, share and comment on my video. Best of luck students. Happy luck.